So let's get this show on the road because I got lots of content to show you guys today. So I might go over my allotted hour. So again, if you missed last week, this is part 2 of the SOLIDWORKS tips and tricks kind of night school series that we did. So my name is Dane and I'm an applications engineer here at Hawkridge. My background is in mechanical engineering, and I have a Bachelor's of Science in Mechanical Engineering from the University of Alberta, and that is all the way up in Canada for our American viewers. So I am our furthest north office, so I get to see the most winter. Lots of fun, but I do get nice, long, sunny days in the summer, so I can't really complain. I have about 17 SOLIDWORKS certifications. So I'm pretty good at SOLIDWORKS, so I'll try my best to teach you guys something new, and I'm sure there'll be something that'll either be a nice refresher where you're, oh yeah, I forgot about that, or something new where it can help you be a little bit more productive. So this is a summary of everything that we covered so far. And by so far, I mean in total. This is our roadmap. So for the first 2 chunks we did last week, so that's the interface and the sketching. And in today's webinar, we are going to do the modeling, assemblies, and then the little extra portion as well. So let's jump right into it. We're going to start off with the modeling section, and I'm going to talk about the sweep tool and some enhancements that have been made to it that you might not be aware of, a quick up to surface reference for your extrusion features, the advanced hole tool, and then the property tab builder. And I'm just testing my bandwidth right now, seeing how long it takes for everyone to catch up to me so I can try and pace my speaking so I don't get too carried away and too excited with myself. So in this model, we can see we have 2 sketches, and it is everything we need for a sweep. There's a profile, which is that little triangle, and then we have our path, which is this helical kind of spring shape. So I'm going to go into my sweep tool, and I can grab my profile and my path. So if we notice right now, my profile is not at one of the end points of my sketch path. It's kind of not in the middle, but not at one of the end points. It's definitely offset a bit. And when you do that, you have some unique options. We can go in only one direction from the profile, or only in the other direction, or we can go in both directions. So if there's a plane that's easier to sketch on, that's not at one of the endpoints of your path, then you can definitely sketch your profile on there, and as long as it has a pierce relation, this sweep will work pretty effectively. There's also an option to do a circular profile, and that saves you from having to sketch a circle if that's what your profile is going to be. So I can come in here, and that saves me one whole extra sketch. I can just define the diameter of the circle and go in from there. So I can also use model geometry as well. So I'm going to use a circular profile, and I'm going to cut away a little notch on the end of this spring here. And for my path, I'm going to grab just this model edge geometry. We can see I'm getting a nice preview, and I've cut myself a little groove in there. So I didn't actually need to make a single sketch for that sweep feature. So that's pretty handy. I can also use faces as the profile. So I have some threads here on this cap, and I need to finish this thread off. So I'll go into my sweep tool, and for my profile, I'm going to use this face, and then I have a path already sketched for me, and then I can see that I have now finished this thread off really nicely, really cleanly, nice and easy. So just that little trick there saves you from having to make extra sketches when you're using your sweep tool. I have a sketch on here, and it's a nice simple circle. And I want to extrude a cut with this circle. And I want it to be intelligent. So maybe this design is still fluid. The thickness of this component might change. So I want to give it an up to surface condition to this back face. So instead of me going all the way into my property manager, hitting my drop down and searching through the list and then always missing it, because that's what I always do every time, I can just go to the face. And if I double click on the face, it will automatically bring me to an up to surface end condition with that face selected. And then I can right click, and lo and behold, I have a nice design intent for this hole to always go through to this face. Right in there, pretty cool. This part was getting reviewed by management, or maybe I made a mistake, and this cut down here, that nice line arc line cut there, is on the wrong face. I need to put it on the back face. So what I could do is I could go into the sketch and change the sketch plane, but there's a move feature command. So I can go into my feature tree. So I'm hovering over this cut extrude 2, and we can see the nice little preview in my graphics area. If I hold down the shift button, I can drag this and drop it onto a different face. And then I get prompted about some dangling dimensions, so I can delete them, but I'm going to keep them. And now we can see that feature is on this back face, exactly where I dropped it. And I can just come in and edit the sketch, reattach one of my dimensions, and then my hole got the face switched. Really easy. So I could literally just drag the feature from one face to another, and that didn't rearrange it in my feature tree at all. It still maintained the hierarchy. So any subsequent child features didn't break and explode all the way down the line. So this next model here you might have seen before, and that's because it's the poster boy for the advanced hole tool. So those of us that don't know, the advanced hole tool is really useful for making multi-stepped holes. So it can keep all of your steps in the hole in one place, but the best part about it is it gives you a nice hole call out in your drawing. So this hole isn't quite finished yet, so I'm gonna edit it and finish it off. So in the property manager, we have this little jutting out section here where I can start defining all my holes. So those 3 I'm happy with. What I want to do is I want to make it a through hole so it goes all the way to the end. So I'm going to give it a far side. And I can define the face for the far side. And now I have another segment of hole. So then I can come in here and start specifying it. So I can grab my standard type. And it's going to be a drill size. And just like the hole wizard tool, this will ensure that I am making holes that are kind of standard and really manufacturable. So I don't have to make custom tooling or anything to make these holes just to bring the price of my design up unnecessarily. So I'm going to add another section, and we can see another section got added in here. And I have a drop down for different styles. I can get countersinks, counter bores, but I'm going to get real fancy with it and give myself a tapped countersink, just like this. And I can come down, grab my size, 1/2, and set the depth of it, just like that. And I'll add one more piece just so I can get a tool in there for some clearance. And it's just going to be a hole, and it'll be a drill size, and it's going to be nice and big right in there. So I want this to only be about 1 mil, just so I have some clearance to get my tool in and out of there comfortably. So that's really good, but that took a couple steps to define. And let's say this is a really common hole that I use for all my maybe injection ports or something, or cooling pathways, whatever it is. So instead of me having to go through all of those steps and redefine it, I have a favorites option. Now this favorites option exists in the hole wizard tool as well, and also for your dimensioning styles when you're inside of your drawings. So I can come in here and I can add this as a favorite, and this is going to be my best hole ever. And I'll hit OK. And now that's the best hole ever. And since this is loaded up now, I can toggle between maybe a different hole and my best hole ever and get to it really easily. So I can save this out as an external file and load it into other parts as well, making my life a lot easier with this multi-stepped hole. So let's change my display state here and really look at the complexity of all these holes. So doing those all as a single revolve feature would be a little bit intricate. And then the worst part would be trying to detail it in your drawing. So that's where the advanced hole really shines, is when you're pulling all of that whole information into your drawing. So speaking of my drawing, this part file needs some file properties that we're gonna automatically propagate in my title block of my drawing. But I'm looking at my file properties and it's empty. So maybe I accidentally chose the wrong template that didn't have it in there, or people are putting spelling mistakes in or not correct formatting, and it's not lining up really nicely. So a good way to standardize your file properties is to use the property tab builder. So if I go over into my display pane, I have set up a nice custom properties template. And as I click on this, it really simplifies the whole process down. So I am going to generate a nice author custom property, and I'm pulling this down from a list because in order for it to fit in my title block, it needs specific formatting and it's first initial last name. And then I can find myself and click on it in there and it's the right formatting. I can also have user input. So this part number is going to be put in there, and I'm just going to throw some numbers in. The material is getting automatically pulled from the SOLIDWORKS file, so that's really handy. And then the date completed as well. So I can click on this and I can have a calendar come up and it'll even tell me what today is. And the nice thing is it will standardize the formatting. So it's going to do my month, day, year formatting, because that's what my computer's set up to do. And then that will be standardized every product you have, so you're not ever getting confused by the dates if maybe some people do it differently. So I can hit apply, and now when I open up my file properties, I can see all of those custom properties have been propagated based on the settings that I had set up. So I know my author's spelt right and formatted properly. I know my date is accurate and also formatted properly. So I have this status of unchecked. So I have another level inside of here as well for review. So maybe when the manager comes in, he can hit the checkbox for review. And then I get a couple more options. So I have another list to see who's checking it, and I can click on that. And we'll pretend he's checking it tomorrow. I'll change the date. I can hit apply. And then up here in my file properties, I can see all of those have been propagated for my drawing. So that's really cool. So you can set those up any way you want, and that is by using the property tab builder. So when you install SOLIDWORKS, there's a couple applications that get installed in the background that not a lot of people know about. So that's your SOLIDWORKS Explorer, your custom or your property tab builder, your treehouse, things like that. And this is just like a kind of drag and drop website builder. That's what it reminds me of. I can grab sections and drag them in and put them where I want them. But I don't want it, so that's okay. And then you can come in here and you can change it around. So you can say, okay, what is my custom property going to be called? What type do I want it to be? And then you can fill in all of your values for the list. And then part number, this one's just going to be text and everything like that. So it's nice and simplified, really easy to do. Anything you want, and you can even drop down and grab your standard SOLIDWORKS kind of custom properties, or type in and make your own custom ones as well. So that was our enhancements on the sweep tool, the quick up to surface when you're using an extrude tool, the advanced hole, and then the property tab builder. So the next modeling we're going to talk about is our tab and slot feature. So that's brand new for 2018. selection sets, direct editing, instant 3D, and then the save bodies command as well. So now that we can all see my screen, I have this nice multi-body sheet metal part. And when it comes to fixturing things like this together, it can sometimes be a nightmare. You take some measurements and you clamp things down, and then you're clamping another piece and you accidentally bump your clamp and everything moves and you have to start all over from scratch. So the tab and slots are a nice fixturing method to kind of alleviate that. If you're using a cutting machine to make your cuts and your bends are accurate, then all of these tabs and slots should line up and hold your parts into place, so then you can come in and do your permanent fixturing like your welds or glue or whatever material you're working with. So that's what we're going to do for this nice multi-body part here. So tab and slots are pretty complicated because it's adding material to one body and it's taking material away from another body. So previously that used to be really complicated, but now with this new tool, it is practically a breeze. So the first thing I have to do is I have to select the edge in which I want to put the tab on. So that's where I'm adding material. And then the face in which I want to remove material from. So that's the slot. So once I've defined those, I start getting a preview. And if you look on my screen, I have a purple node and an orange node and green, that is green. I have a purple node and a green node. And from those two endpoints, I can set some offsets. So if I need to make sure I have a certain amount of clearance to clear another feature, I can define it that way. And then I can start equally spacing out my components and my tabs and slots. Or I can hit the spacing length and manually space them out. Again, really convenient if you need to avoid features. But I'm going to keep it easy, equal spacing, 20 mil offset from the endpoints, and only have 2 of them. The next thing I can do is I can change the length of my tabs and of course slot, and the height as well. So right now I have an up to surface end condition, so it's going to sit flush with the surface. And in here, I can also maybe blindly extrude them or do an offset from surface. So if I want my tab to come all the way in or inlay a certain distance, then I can have enough room to put a weld in there, I can do that as well. But I'm going to keep it simple with a nice up to surface. And I can add a fillet in there or a chamfer to make my life that much easier. I don't have to come in and do it later. So I'm just going to put a big 3 mil chamfer in there. And then finally, I have my clearance. So I'm going to put a 0.2 mil clearance, and that's going to happen on every face that needs a clearance. So that'll be on both sides that I'm putting that 2 mil on there. So I like that. I'm happy with it. I will hit my checkbox, and there we go. I have my nice little tab and slot. So if you've ever worked with weldments, the tab and slot feature is similar to weldments in the fact that it allows grouping. So I set up all of those parameters in my property manager, my offset, my spacing, my length, yada, yada, yada. And I don't want to have to redefine that every time, so I can set these into groups. So I can make a new group here, grab an edge, and loop around, grab my face, and there we go, my tab is made. And again, make a new group, grab my edge for the tab, grab my face for the slot. And just like that, I have made myself a nice little self-fixturing multi-body sheet metal part. Pretty cool, nice and handy. Will make your life easier if you are doing fixturing, or even if you have been doing tab and slots, this is substantially easier than having to do it, because if I make a change, it's going to be associative and it will automatically update. I have this panel here and it's got some holes to it, and this is an imported part. So maybe I'm getting this from a a vendor and they're giving me a neutral file, or whatever the reason is, I don't have a feature history to this. And I want to make a change to this. And the change I want to make is I want to move all of these holes into a different location. So the whatever's mounting to them still needs the same hole pattern, but I want to move it in my overall assembly. So I'm going to use my move face technique, which is one of my direct editing techniques. But in order to move all these faces, I first have to select them all. So I'm going to come into this one face, select my tangency, that'll grab that loop, and hold down Control and grab all my other little holes. But I'm not 100% sure where I want to move this. I might want to resize these as well. And I don't want to have to grab all those clicks again. So what you can do is you can save your selection set. So if you've selected a certain amount of components, you can save that selection set by just right-clicking and hitting Save Selection. So I'm going to do that. And then in my Property Manager, what I can see is a new selection set folder where I can then pick my selection set and it will grab all of those selections, saving me from having to do it again. So now that I have all of those components selected, I'm just going to do my move face. And what I can do is I can literally just move all of those faces with this direct editing technique. So I didn't have any feature history or anything like that. I just selected the faces and I moved them exactly where I needed them to be. When I'm making fillets, I sometimes don't know the best size to make that fillet. And that's where my instant 3D comes into play. This is my favorite thing to use this for. So if I click on a fillet, I have my dimension, and what I can do is I can grab the dimension and I can drag this and change the size of it. And in real time in my graphics area, I can see the size of my fillet changing. So I can get a visual understanding of the difference between the 5 mil fillet and maybe a 10 mil fillet. And I can see how that interacts with other components around it and everything like that. You can also use your Instant 3D to change pretty much any dimension. So maybe the location of this I don't quite like, so I can come in and slide it over. Maybe change that dimension to 30. And I can pull this one up and move it right up here and snap it to my ruler. And then the location of that has changed and it hasn't destroyed any of my features. It's not creating a new feature. It's just changing some of those dimensions in the sketch and letting me see exactly what that looks like on my 3D model. This Weltman feature here has a cut list. It's got 33 components to it. Now, for whatever reason, I want to save each one of these cut list components as its own file. So maybe I want to do an interference detection, or maybe there's some potential motion in here and I need to put it into the assembly environment, or maybe some of these parts are getting manufactured by one person, some other parts are getting manufactured by a different person, and I don't want to send them the whole file and confuse them. I want to split it all up. So I can do that really easily. If I right click on the cut list folder, I have this save bodies option. And what that's going to do is that's going to take each one of my bodies in this part file and save it out as an individual part file. I can also create an assembly from there where it will take all of those part files and create an assembly and locate them based on the location in this part file. So I'm going to make myself a nice assembly. And once you do that, you have this option to derive resulting parts from similar bodies on the cut list. So we can see here that this orange and purple part are the exact same dimension. So instead of SOLIDWORKS creating two of them, what it's going to do is it will create one of those solid bodies and then use two instances of that part file inside of the assembly. So all I have to do is hit my select all. And if I uniquely named all of these bodies, they would come up with really nice, unique names. Unfortunately, I didn't do that, so they just have the last feature applied to them. And if I hit the check mark, my computer will sit here and open 30 files, so I'm not actually going to do that. But if I hit the check mark, it'll make a part file for every single one of those bodies for me. So that was our tab and slot, selection sets, direct editing, instant 3D, and the save bodies command. To finish off the modeling section, I'm going to talk about 3D interconnect and then the new mesh bodies type inside of SolidWorks. So 3D interconnect lets you work with third-party design data. So like this graphic shows, that means I can open my Inventor parts, Pro-E parts, Rhino parts, CATIA parts, whatever I need. And it's not converting them into a SolidWorks part. It's not translating them. It's opening up in its native file format. And that's really nice because it will honor the face and edge IDs of those parts. So if I take an Inventor part and put it into my assembly and I mate a certain face to my assembly, and then I go into Inventor or the supplier sends me the Inventor file and I update it, SolidWorks is going to remember which face that it mated with, and it will update that part, really similar to like it does when you make a change with the SolidWorks part. 3D Interconnect also works with your neutral file formats as well, so your step files, IGES files, ACES files, and it can read reference planes and custom properties and material properties, unconsumed sketches and curves, and reference axes as well. So really handy for working with that third-party design data. So when you saw that PowerPoint, you might be saying, well, what are mesh models? Well, mesh models are just a tessellated version of your geometry. So it's your model, but made up of little triangles. And some of the common formats are your STL, OBJ, and 3MF. So you might be sitting there being like, yeah, Dane, I use SolidWorks. Why do I care about these other file formats? Well, it's the output that you're going to get from a 3D scanner, and it's the input that a 3D printer is going to expect. So those two things are getting really popular nowadays, 3D scanning and 3D printing. So there's even some mesh modeling file sharing sites that are starting to pop up, like Thingiverse and TurboSquid. So with SolidWorks now and being able to edit these mesh bodies, it opens up that resource to you. So previously in 2017, the approach was you take your 3D scan and you'd import it as an STL. And then if you wanted to make any changes to it, you'd have to convert it into a SolidWorks surface or solid. And that was a lot easier said than done. If anyone's ever tried that, that was could be a painful process sometimes. And then you could finally modify it, and then you had to spit it back to an STL in order for it to finally go out and print. So what we can do now in 2018 is we can work with these mesh files. So we can leave it in this tessellated STL format and do our modifications there and then spit it out to print. So it got rid of that painful conversion process. So what I'm going to show you is I have a scan of this nice little bottle. I love the feel of it. I love the shape of it. And I'm just going to brand it for Hawk Ridge Systems. So I'm going to bring it in, and I'm also going to use some of my standard SolidWorks techniques, create a solid body, and then I'll convert the solid body to a mesh body so I can combine those together. But that'll make a bit more sense when I actually get into SolidWorks here. So I'm going to open up this STL file. And whenever you're opening up a file that's not a SolidWorks file, if you go and actually choose that file handle in your filters, you'll have a quick button to get to the options. So I'm just going to double check my options, and I could import it as a solid or surface body. However, for the sake of this exercise, I'm just going to leave it as a graphics body. And I just wanted to double check my units. So this was saved in metric, so I need to make sure I open it in metric or I'm going to have some scaling issues. So I'm going to open this STL up, and it's metric, so I'll use my metric template. And I can see I have this nice tessellated graphics. So this is literally just graphics. As I can see in my feature tree, it says graphics, and I can't really do anything with it. I'm not stealing the design for the lid. I don't want the pump lid, so I'm just going to delete that. I only want this shape and contour. So if I look at this, I can see it's infinitely thin. It's like a surface because it was just a scan of the outside face, and that is all the scanner did, was just make me a smooth surface there. So if I want to 3D print this, I need to add some thickness to it. So what I'm going to do is if I right click on my graphics body, what I can do is I can convert it to a mesh body. And then this is the new file type in SOLIDWORKS. So now when I look at this, it looks like a SOLIDWORKS surface. It has that characteristic blue end for any open ends. And the color changed as well to my default color. And now that it is this mesh body, I can use my surfacing commands on it. So I can come in here and I can thicken this. And 3/4 of a mil looks pretty good. And when I look at it now, I have some depth to this geometry. There are 2 triangles going across the thickness now instead of just one. If I click on it, it'll turn blue, and then we'll be able to see that a bit better. There we go. Nice tessellation to it. So I want to add some threads to this. But I love my thread tool. My thread tool, unfortunately, doesn't work on these mesh bodies. So I made myself a part with the threads, and I'm just going to import that in. So I'm going to come in here, I'm going to import my part, and now I have a solid body, which is my normal SOLIDWORKS body, and I have this mesh body. And right now the 2 are kind of incompatible. They can't really cross communicate with each other. So I'm going to take my solid body and I'm going to convert it into a mesh body, and it's just going to tessellate it, turn it into those triangles. And now I have these 2 bodies which can communicate with each other. And since they're of the same type, I can now combine them with my Boolean operations. So I'm just going to add them together. And now I have one single solid body, which is an STL. It has all of my little triangular tessellations. So I can now save this as an STL and get that printed out on a printer really, really easily. And most importantly, do the modifications really easily. So some of the other operations you can do on these mesh bodies is you can intersect, split, you can move, copy, cut with surface, delete them, shell, boss thicken, cut, thicken, and scale, surface offset, trim and extend, split line, lots of operations. And there are more to come. So that is it for the modeling section. I'm now going to move into assemblies, and I'm going to start off with the profile center mate, the advanced selection tool, replacing components, copying multiple components, mate references, and the multi-mate mode. So I have this assembly here, and I want to take the plate I just clicked on, and I want to mate it to this other plate. So just thinking about it, I'd have to make those 2 faces coincident. So that's one mate. And then I'd have to stop it from moving up in the Y direction and in that X direction. So I'd have to do some sort of either distance mate or coincident mate with some of those edges to make sure they don't spin and make sure they don't translate. So that's at least 3 mates that I would need to get this plate fully defined. However, that's where the profile center mate comes into play. So that is one of my advanced mates, and what it does is it will take the center of the face and it'll make it coincident with the other component. So that will give me my nice 3-in-1 mating scenario. So it isn't actually creating 3 mates, it's just getting rid of all of the degrees of freedom that those 3 mates would do. So that's pretty cool. That makes my life a lot easier. I'm going to do the same thing for this bolt as well. Grab this circular edge, and give it a profile center. And that will do the same thing as doing the faces coincident and those cylinders concentric. So a nice little 2-in-1 right there, making my life simpler and more effective and efficient. I have 3 knobs on this component, and I want to change those knobs. So instead of me having to control select them in the graphics area or in the feature tree, what I'm going to do is I'm going to go down in my selections, and I can select identical components. So once I click on that, I can click on a component, and we can see that all the components that are the same, or all instances of that component, will be selected. So I'm going to come in here and I'm going to change the configuration of it to my new stud. And then, of course, I have a bunch of errors, because why wouldn't I? So let's dig in and let's see what I broke here. So I'm going to use my breadcrumbs, and it's just a mate error. So once I edit this mate, I can see that I have a missing face. So the face that was mated initially doesn't exist in this new configuration. So I'm just going to replace that with this face that I have here. It's pretty simple. It's the cylindrical one. And I'll hit OK. And now I get this warning that comes up. And it says there's other mates with the same missing reference. Would you like to replace the other missing references with the one listed below? And I'm like, yes, sir, I do. I don't want to have to do that 3 times. So thank you, SOLIDWORKS, for saving me a whole bunch of clicks right there. Awesome. Love it. So as we can see here, my support pillar needs another one of these arms. Now, I didn't make these arms as a subassembly, so I can't just import them as a subassembly, but there's a whole bunch of mates in there, and I don't want to have to redo that. So if I look at my mate folder, I can see that, yeah, I do have a whole bunch of mates. So I'm going to categorize these now into a folder, and I'm going to say they're my left side. And what I'm going to do is I'm going to copy all of these ARM components. And when you copy multiple components inside of an assembly, all the mates between the copied components will also get copied over as well. So I'm going to grab all of these components, hold down Control, and drag them over here. And I can see I have all of those components copied over for me. That looks good. I'm happy. I can come down at my mates, and I can see outside of that left side folder, I have all of those mates copied for me as well. On the right-hand side, when I scroll through them, you can see my graphics area strobing with color over there. So that's awesome. That's exactly what I wanted. That saved me, again, a bunch of work. So I now need to locate this component. So I'm going to use my profile center again. And when you're using that profile center, there's different possible orientations. So I can rotate this component in different directions, and we can see all the possible orientations that come along with all those directions. So this is the one I want. And let's move my piece back exactly where I want it to be. So in reality, I'll be able to move this component completely out. But I want to kind of set up an initial position for this. So then I can always have my assembly looking the way I want it to. So using a configuration with mates and suppressing and unsuppressing them is a really good way to do that. But some people don't like configurations or want to avoid them. I'm going to show you a couple other ways to do it. Inside of your mate tool, at the very bottom, there's an option for use for positioning only. So when I check that on, and I grab my 2 faces in the graphics area, and add this mate, it's only going to position these components. So when I look down at my mates, no concentric mate actually exists in my mate folder, and I can move this component still. So that mate didn't actually get created, it just lined it up temporarily. So that's kind of good. But if I want to reline it up again, that's more rework for me that I don't want to do. So I'm actually going to create the mates. Just give myself a coincident mate at the bottom and a parallel mate for the arm. And what I'm going to do is I'm going to grab those mates in my feature tree, and I'm going to put them inside of a folder, and I'm going to call that folder my initial position. So right now this is locked in place. If I wanted to move, I can just suppress that entire folder, and then I have the freedom to show the motion. And then when I want to get it back to that initial position, I can just unsuppress this. So that's very similar to having a configuration that you toggle between, but I just have it as a folder. Whoop. There we go. My screen is catching up, getting some lag over here. So for this clutch assembly, I have a whole bunch of rings, and I want them all to line up upon the same axes. So instead of me going one at a time, click, click between, add concentric, click, click, add concentric, in my mate tool, I have this multiple mate mode option. So when I click on that, I can even create a folder where all those mates are located. My first click is going to be my common reference, and then all of my next clicks are going to be what I'm going to mate to that common reference. So right in there, all of those components got mated in one fell swoop. I didn't have to create a whole bunch of mates. All the mates are independently created, so we can see I do have 3 separate concentric mates, and they are categorized into the multi-mate folder. It just saved me from having to re-click that first reference mate every time. So cut my clicks in half. Nice and convenient for me. So that was our profile center mate, advanced selection, replacing components, copying multiple components, mate references, and the multi-mate tool. I am then going to talk about mate controller, speed packs, and magnetic mates. So with this picker assembly I have here, there's a lot of motion this thing has. There's a lot of unrestricted degrees of freedom, and I want to try and make some configurations so I can document it and maybe have some awesome marketing collateral that I make in Composer or something. But in order to do that, I need some configurations, and it's kind of difficult for me to get it exactly where I want by just grabbing in the graphics area. I could go to some of these open-ended mates and change their values and lock them in and make the configurations that way, but that's a tedious manual process. To solve that problem, we have something called the mate controller. And what the mate controller does is it will take all of your limit mates or any open-ended mates and categorize them for me. And what I can do is I can either change the value with these arrows, numerically change them, or even grab a slider to get the exact positions I want. I can have this come down a bit, reach in, twist. Everything I want it to do, I can grab via these sliders. And then I can save the position by adding a position, and I can even save positions as a configuration as well. So now that home position is a configuration, maybe I have my box gripping, that'll be a nice configuration where I place it, and then that can kind of show the full range of motion that this assembly is going to have. I can also really easily create animations between the positions. So all of the positions I've saved, I can set the amount of time I want my mechanism to move between those positions, and then calculate the animation. So right here, it looks really good on my screen. Our bandwidth might cause it to be a bit choppy, but I'm sure you get the idea of what exactly this does. And then I can save that animation as well as an AVI file and then send that out and do with whatever I want to do with it. So this picker robot is going to go into my factory. And my factory is really large. I have a whole bunch of conveyors. I have a whole bunch of product, and I got multiple picker machines as well. So that's going to be a really, really big assembly. And I'm not 100% sure about my layout yet. So let's imagine right now all the mates I would have to do for this robot. So the first thing I'd have to do is I'd have to ground it. So I'd take one of these bottom faces and I'd mate it to my ground plane. And then I'd still have translation on the XZ plane and rotation as well about Y. So maybe I'd have to make this face that I just clicked on and it turned blue. That face would be parallel to my conveyor frame. So that's another mate I'd have to add. And then I'd have to set it a certain distance away from it as well. And then I'd also have to maybe set a distance for this face from the edge to locate it along the conveyor. So that's 3 more mates I'd have to add. And then if I want to make a change, I'm like, oh no, I don't like where that robot is. I want to move it. Then that's a whole bunch of mates that I have to sit there and manipulate. It sounds like a logistical nightmare right now just thinking about it. So what I can do to solve that issue is use magnetic mates. And magnetic mates just turn this into a drag and drop operation. It's really nice. So I'm going to go into the asset publisher, and that's what you use to generate magnetic mates. So I'm going to turn this entire robot into an asset. I'm going to define my ground plane, and my ground plane is going to be a common plane that all my factory components share. And then I'm going to create a connection point. So my connection point is this blue little orb down at my screen by that arrow, and that's going to be looking for another connection point to mate to. So it's going to bring all of those mates down into one little mate. And also in this asset publisher, I can create speed packs. So this is a really large assembly. I don't need all the parametric information for this robot in that giant assembly. So this speed pack will just pull it in as graphics and really only bring in the information I need for the magnetic mate. So I'm going to check that on, and I'm going to make that, and let's check out my factory layout here. So all of these components are speed packs. So when I hover my mouse over them, you can see a lot of the information disappears. And the only information that's actually loaded into my RAM is what I've told it to use. And that's the things I'm going to use to mate with. So I'm going to grab one of these robots and I'm going to make a copy of it. And you can see all these little purple bubbles start to appear on my screen. And those are all of my magnetic mates. So once I have 2 of those bubbles connected, I can let go and we can see my robot slid right into place. I'm going to make another one and I'll put this one at the back. And you can see once I put this robot at the back, it has a nice little spin to it and orients the exact way that I want it to. I can also toggle between my little mating nodes as well, using some keyboard shortcuts to relocate the component. So when I put it on that side, it automatically rotates nice and easily. So again, maybe I need this conveyor piece to be a bit longer. I can have it turn and add another conveyor piece in there. So it really helps with these layout designs and changing your mates really easily. Pretty awesome new feature for SOLIDWORKS. So that's it for our assembly environment. And we just talked about the mate controller, speed packs, and magnetic mates. So to finish this off, I'm going to go into the extra section. And I'm going to talk about drawings first. So we're going to align some drawing views, do a relative to model view, custom detailed view, multiple leaders, and then my personal favorite, the good old spell check. So I have this drawing file. And I'm looking at my view here on the right-hand side. So this is that 4-bar member that I made last week, if you were here and remember. And this one component's at an angle. It's all shifted, so it's eating up too much space on my drawing view. It's kind of deceiving on which one it is. Is it longer than that other one? It's hard to tell. So I'm going to rotate it to try and line that up. I'm going to rotate it by 30 degrees. That looks kind of good, but I'm zooming in, and I can see this vertical line here is still jagged. It's choppy. So this is CAD software. I expect the lines to be really straight. I could almost do that better with a pencil. So what I'm going to do is if I pre-select the line, I can go up into my tools and I can align the drawing view about that edge I have selected. So I'm going to say that that blue edge I have selected is going to be a vertical edge, and it will rotate my view to make that perfectly vertical, and now it is no longer jagged. My little yellow crank over here is the last piece that I'm missing. So if I look at the part file and I look at my front view, it too, unfortunately, is angled. So what I'm going to do is I'm going to use a tool called my relative view. And what the relative view allows me to do is it allows me to define what I want to be the front and other orientation for my part. So when I'm in my part file, this blue face, that's going to be my front, and my second face will be my top, and I want that pink face right there. That will become my top view. So now this component is oriented the exact way that I want it to be, and I can place it down no problem and use my model items to bring in all of my parametric information. So I want to make a detailed view. And sometimes this circle gets in my way. It's too big. I can't cut exactly where I want to cut, and I'm intersecting my other view. I'm eating up too much real estate on the right. So I want a custom kind of profile for my detail view. So if I make a sketch, and I'm going to make myself a nice little rectangle here and keep it nice and tight so it doesn't eat up all my space, and I have this sketch pre-selected right now, and then I click on my detail view, what that'll do is that will let me use that profile. So you're probably looking at this and like, nah, Dane, you messed up. That's still a circle. What are you doing, bud? But if we look at the top, we can see that I have a nice flat cut. So I didn't make a mistake yet. What's going on is my detail circle style is set per my drafting standard. So what I have to do is I have to change that, and I'm going to go with leader, and then this radio button for the profile appears. And then I can click on it and I get my custom profile to the rectangle. And now look at that, everything's lining up. It is not eating up all of that space. I'm adding a note in here, and I want this note to tell me that I need to leave room for a bushing right in there. And I want that at every single connection point. So instead of me stamping this words 3 separate times, what I can do is I can just drag the leader. So if I click on my note, hold down Control, I can drag the leader and I make a copy of it, and I can place it down into a new location. So again, I hold down Control and I click and drag my leader, and I can make a third leader in there. And now all of these leaders are linked to that one note, and I don't have to stamp that dialogue over and over and over again all over my screen. So that's looking good. And then my personal favorite tool is the spell checker. So lots of people don't like this tool. What it does is it will go through your notes and dimensions, and it will look for spelling mistakes. But lots of people have maybe company names in there or abbreviations, things like that, part numbers. So what you can do in your more options is you can ignore things that are all uppercase, or ignore words with numbers, or ignore capitalized words that are names, things like that. So then the spell checker can be a bit more effective for you and a bit more efficient. You can also have it run on your title block. You just have to make sure you have your sheet format open. The spell checker will not run in any tables though. So it's only dimensions and notes. So that was a quick little drawing section there. We aligned some views, got everything to line up nice, multiple leaders coming from our notes, and then looked into those spell check options. So finally, to finish this off, I'm going to talk about topology optimization and then some Hawkware tools as well. So a big part about simulation is the ability to optimize your designs. So currently in SOLIDWORKS, there's only parametric optimization, which needs a lot of input from the user, and it's restricted to which parameters you select to optimize. So it's a lot of human intuition involved. So I have this part right here, and this is for a hood mechanism, and I want to try to reduce the mass of this piece without compromising the connection points or the structural integrity. So I asked a colleague of mine to try and optimize it using kind of the standard design methods right now, so just the parametric optimization, and I'm going to compare it to SOLIDWORKS' new topology optimization. So the topology optimization is this generative design process, and it's going to determine new geometry using the stiffness matrix of the FEA, and it's going to give me some geometry that I couldn't even fathom. So it uses technology from Tosca, which was previously only available in Simulia. So a topology study performs a non-parametric topology optimization of your parts. So it starts with a maximum design space, and it considers all your loads, fixtures, and manufacturing constraints, and it seeks a new material layout within the boundaries of your maximum allowed geometry. So it'll run to a goal. So it can reduce your weight to stiffness ratio. It can maybe minimize your maximum displacement, or it can minimize your mass with a displacement constraint. And then some of the manufacturing controls you can put in there is to preserve thickness, don't remove material in certain regions, demold directions, and you can force symmetry as well. And then you have a couple export options. So let's see what that looks like inside of SOLIDWORKS. So here's my hood hinge assembly, but I am just optimizing this little bracket in here. So I can see right now that I have some fixtures. So this blue face on the inside, I'll zoom in a bit. That's where I'm connecting a bearing. That's one of my boundary conditions. Right at the top, I have another boundary condition where I'm connecting a bearing. And then I have a roller slider on the back face right there, which is where it rubs against the where it's connecting to. I'm then applying a load. So from the actuator that's pushing up on it, and the weight of the hood, and maybe someone leaning on it as well. That's all been accounted for in this load. So those are my boundary conditions. That's the simulation. That is what I need to ensure passes while SOLIDWORKS starts removing material. So I have some preserved regions. I said, okay, SOLIDWORKS, where I connect the first bearing, can't remove material there. Where I connect the second bearing, you can't remove material there. And then where my loading is happening, you cannot remove material there. And I set my goal here to be find the best stiffness to weight ratio. And I am trying to reduce the mass by 75%. I'm being really ambitious here. So I have a finished study, so we don't have to sit there and watch that run. And this is the results I get. So I used a really coarse mesh to allow this to run a bit faster. And you're gonna see that in my results. So for those of us that don't know, when you're doing a simulation study, your model is broken up into little elements or blocks, like little bricks. And we can see all those represented here. So if I zoom in on one of these pieces, we can see how coarse my mesh really was. The bricks are really big. So if I had a finer mesh, I would definitely get a smoother surface. But this gives you a pretty cool looking piece here. And it would be really hard to just imagine the exact kind of mesh geometry there, or crisscross support that this component actually needs to solve that loading scenario. So from here, I can export this out as a graphics body, solid body, or surface body and work with that as well. So that's pretty cool. So the results of the little challenge I had are going to come up right now. So the original part has a mass of 167 grams, and when I ran that static study on it, it had a factor of safety of 3. So it was 3 times too strong to solve all of that simulation. So my colleague here just gave a nice kind of angled slot and used the parametric optimizer to remove some material. And he got about a 23% reduction and was just passing the simulation. So I took a graphics body and used the mesh modeling techniques to actually make this model here. And I got a mass reduction of just under 60% and a factor of safety of 1.06. You can see it's just as strong as that previous part. So it's just as strong as that part, but a lot lighter. This part, however, would be pretty hard to market to people, pretty hard to sell. So I did a redesign based on the location of the supports in there. And this is what I got. I got a mass reduction of 54% and then a factor of safety of 1.1. And then this is a part people can be confident and comfortable with. So the last thing I'm going to talk about is Hawkware. And Hawkware is a division of SOLIDWORKS where we write custom applications for people. So if you've ever used Pack and Go, that was originally developed by these guys. So they really know what they're doing. But I'm just going to touch on a couple of the cool free tools that they give away that you can use inside of SOLIDWORKS. So the first one's a deactivation reminder. So when you turn your SOLIDWORKS off, it will flag you and be like, do you want to deactivate your license so you can activate it on a different computer? So then maybe if you drive all the way home and you want to open it up on your home computer, your license isn't being eaten up by an idle computer at the office. There's a fillet renamer, so it can grab all of your fillets and rename them based upon the dimension that they have. There's a drawing creator. So if you have a really good drawing template that has predefined views and you've annotated your model correctly, you can tell the drawing creator to make a drawing file for every part within an assembly, or maybe every file in a folder, something like that. And it'll use that template and pump out some pretty good drawings. And you just got to go in there and tweak them a bit, saving you a whole bunch of steps. Then there's user macros. So they can either write custom macros for you, or if you put the user macro inside of Hawkware, it lets you link them to certain file events like opening, saving, rebuilding, things like that. And then there's a configuration exploder as well. So what this will do is it will take all of the configurations within a part and then save each one of those configurations as its own part. So if you've ever tried to do that manually, that is a fairly tedious task. So I'm going to talk about one case study they did. So there was a company we were working with, and they needed an STL file, so a neutral file for every model they had. And what kept happening is guys would make changes to the SOLIDWORKS model, but forget to update the STL file. So then they were having things sent to clients that were out of date, and it was just a nightmare. So what the Hawkware team did is they created a macro, and it will save it as a, sorry, I keep saying STL, I meant step. It'll save the part as a step file every time I save my SOLIDWORKS file. So that's pretty cool. So if I pull my SOLIDWORKS kind of to the side here, and I'm gonna pull up just my Windows Explorer. We can see I have my file here, and I'm gonna save my SOLIDWORKS file. And in Windows Explorer, we can see that step file magically appear. So I'll do it one more time. I'll delete the step file, and I'll come in here and I'll save my SOLIDWORKS file, and it will create that step file for me. Pretty handy, pretty convenient, really cool thing. So I just got to make sure I turn that off so I don't accidentally make step files anytime I'm doing my modeling. So that is my entire presentation for you guys. I apologize that I went a little bit over, and I have been ignoring your questions. I have seen them, and I will get back to all of those questions now. So thank you for attending. I hope you learned something and enjoyed the show. I will now start dipping into those questions. And of course, if you have any, start firing away in the chat there, and I'll try my best to help you out. Can the save bodies be used to give the new part files sequential part numbers or names? That would be awesome. Unfortunately, no. I can go in there and manually name them all as well. So I can tell it to prompt me every time it saves, and I can just give it like 1, 2, 3, 4, 5, or type in those part numbers. Or you can use some of the task scheduler or PDM to go in there and rename all those files afterwards. Will Topology work with 2017? No, Topology is exclusive to Simulation Professional 2018 version. Okay, how do I repair out of context or broken references? Okay, out of context references, if you right click on the part that is out of context, there will be an option there to edit in context, and then it'll open up wherever the reference was created. You can also list all of the external references, and you can delete them to remove the references like that. Broken references, you can only delete. Once you break a reference, you can't unbreak it. That's why freezing them is better. But there's a whole course on that in the assembly modeling class. So I really recommend, if you're confused about the references and things like that, jump into that class. That will definitely help. All right, I think that was all the questions. Let me look into that tab and slot now. If anyone else has any questions, please feel free to throw them my way. Right on. Thanks, everybody. Enjoy the rest of your week. Thanks for attending.